Sixth problem. P is a point in the interior of a parallelogram ABCD. So in this parallelogram ABCD, there is a point P. Show that area of the triangle APB plus area of the triangle PCD. If we add these two, we will get the half of area of the quadrilateral ABCD. So let us start. In solution, first of all, we will draw a line which is passing through P and parallel to AB and CD. So let this line be EF. So construction, draw a line passing through P and parallel to AB and CD. Next, because of this, EF is parallel to AB and EF is parallel to CD. That means these are two parallelograms. This parallelogram is divided into two parallelograms. So we can write, since EF is parallel to AB and AB is parallel to CD, therefore parallelogram EFAB is a parallelogram. Similarly, quadrilateral EFCD is also a parallelogram. Next, these are the two parallelograms. For these parallelograms, we will now see where is the base and where is what are the two parallel lines. So let us see this EFAB. In this, we can say that since triangle APB and quadrilateral EFAB are on the same base, that is AB, and between the same parallel lines. So what are the lines? AB and EF. So between the same parallel lines, so that's why we can say that triangle, therefore the triangle APB is equals to half of the area of the quadrilateral EFAB. This is our first point or first equation. Next, again we can see the parallelogram EFCD. Since triangle PCD and quadrilateral EFCD are on the same base, and base is CD this time, and between the same parallels between the same parallels. So parallel lines are CD and EF. CD and EF. That's why the area of the triangle PCD is equals to half of. So therefore, area of the triangle, we can write AR for area. So area of the triangle PCD is equals to half of area of the quadrilateral or parallelogram EFCD. EFCD. This is our second equation. Now from first and second, if we see, if we add this, adding first and second, area of the triangle APB plus area of the triangle PCD is equals to half of area of the parallelogram EFAB plus half of area of the parallelogram EFCD. Now if we add area of the triangle APB plus area of the triangle PCD is equals to half is common, and if we add these two, we will get area of the parallelogram, EFAB is added to EFCD. That means this complete parallelogram will form, that is ABCD. So area of the parallelogram ABCD. So it is the first bit which we have proved. Second bit, area of the triangle APD plus area of triangle PBC. We need to prove that these two area of triangles are equal to APB and PCD. These two triangles are equal to these two triangles. So let us write. We will start from construction. This time we will draw a line. Construction. This time we will draw a line vertically. So let this be GH. Draw a line passing through P and parallel to AD and BC. AD and BC, they are it is parallel to AD and BC. Next, since GH is parallel to AD and also parallel to BC, this parallelogram is divided by GH. So this is also parallel to them. So that's why this becomes one parallelogram and the other one is also a parallelogram. So let us start. Let us write. Therefore, parallelogram quadrilateral ADGH is a parallelogram. Similarly, we can prove for BCHG is also a parallelogram. Now we are having these two parallelograms. If we see the first one there is a triangle on the base AD. So the base is AD and the parallel lines are AD and GH. So let us write, since triangle APD and parallelogram or quadrilateral AGDH are on the same base. So what is the base? Base is AD and between the same parallel lines. Between the same parallel lines. So what are those lines? AD and GH. So for these two figures, we can say that area of the triangle is half of the quadrilateral AGDH. So therefore, area of the triangle APD is equals to area of the quadrilateral AGDH. This is our we can say second equation. Third equation. Next we can say for this quadrilateral, in this quadrilateral we can say that PCB. So triangle PBC, since triangle PBC and quadrilateral is GBCH. GBCH are on the same base, and so what is the base? BC and between the same parallel lines. So what are those lines? GH and BC. GH and BC. Now we can write that area of the triangle is PBC is equals to half of the parallelogram GBCH. So this is our fourth bit. Now we will add third and fourth. Adding third and fourth. So you will get area of the triangle APD plus area of the triangle PBC is equals to half of the area of the quadrilateral. It is half area of the quadrilateral AGDH plus half of area of the quadrilateral GBCH. Now we can take out half common. So if we add this to AGDH, that is this part, and GBCH is the other part of the quadrilateral. So we will get the whole quadrilateral, that is quadrilateral ABCD. So area of the triangle APD plus area of the triangle PBC. So this is the second bit we have proved, or we can say fifth. In the first bit we have proved that area of the triangle APB plus area of the triangle PCD is equals to half of the area of the triangle ABCD. From these two, from the first bit and and this fifth equation, we can say that now area of the triangle APD plus area of the triangle PBC is equals to area of the triangle APB plus area of the triangle PCD. These are equal. Okay, we will not write that. From first bit, hence proved.